Okay, so in this first video, we're going to look at some circle basics, some circle vocabulary, and some different characteristics involving circles. And in the second video, we'll expand upon that into arcs, into central angles, and being able to look at arc addition, and then also the relationship between a central angle and then the measure of an arc. Okay, so now first looking at this, when we're talking about the circle basics, some of this we've been through before. For instance, we know that a circle, and if you need to, hit pause and you can write down the definitions here. I wrote out the definitions ahead of time to try to save some time in the video here, okay? But we know that a circle is a set of all points in a plane that are a given distance from a given point in the plane called the center of the circle, okay? So in other words, what we're talking about is each point that lies on the circle is the same distance from the center, okay? No matter which point we're talking about on the circle, it's always going to have that same distance from the center, okay? And that distance is the radius, okay? So the radius is a segment whose endpoints are the center of the circle and the point on the circle, okay? So that distance we're referring to from the center to a point on the circle, that guy right there is our radius, okay? That fixed segment, that fixed distance at any given point on the circle to the center, that's our radius, okay? Now the thing about naming a circle, we haven't actually named a circle before, but when we name a circle, we call a circle by its center point. For instance, we could call this circle A, where they kind of put like this little circle guy here with the center and say that this is A, okay? So we call that circle A, based on what is the center point of our circle, okay? And it says the radius of a circle is the fixed distance from the center to the edge of the circle, which I mentioned before. But a circle is unique in the sense that that radius is the only thing that really defines this two-dimensional object, okay? So this distance is the only thing that defines this object versus, like, if we were talking about a square, we can break other properties and characteristics of a square. But the radius is what's defining our circle. Since all aspects of the circle's size depends on the length of the radius, we can change the size of any circle simply by dilating, making it larger, making it smaller, the radius, okay? So if we enlarge the radius, we have a larger circle. If we make the radius smaller, we have a smaller circle, okay? So that's what's defining the size of our circle, is this distance, our radius, okay? Now, another thing that we talked about before, but just kind of reviewing that aspect, is the circumference. And we know that the circumference is the distance all the way around the circle, okay? So if we find that distance all the way around a circle, we're talking about the circumference. Now, some things that we haven't talked about that we're getting into here, okay, is a chord. It says a chord is a segment whose endpoints are on the circle. Okay, so when we talk about a chord, it seems similar to other things. You know, we've talked about radius and diameter, but what separates a chord here is a chord is any segment whose endpoints are on the circle. For instance, AB here, this segment would be a chord, okay? Technically, even though EF we've talked about before as being the diameter because it goes through the center here, technically this would also be a chord. It just so happens that this chord happens to also be the diameter. And CD would be a chord because we have 2 points that lie on the circle, okay? So a segment whose endpoints lie on the circle, that's a chord, okay? The longest possible chord in a circle is one that passes through the center, okay? Through this center point right here. And that's called, just as we've talked about before, the diameter. Okay, so the longest possible chord you can have is the diameter, which goes through the center of the circle. And when we draw in that diameter, let's kind of backtrack here. Okay, when we draw in this diameter FE, okay, that divides our circle into 2 halves. Okay, a diameter divides the circle into 2 congruent arcs. These congruent arcs are called semicircles. Okay, semicircles. So it divides our circle into 2 halves here, 2 semicircles. This guy and this guy. Okay, so that would be the two halves that we're talking about, these semicircles. And a semicircle has an arc measure of 180 degrees, which we'll talk about that later, but basically we're just talking about the portion that's covered, the relationship between this central angle here. We know a straight line has a measure of 180 degrees, so the arc measure, as we're going to learn later, this arc measure would also be 180 degrees. Okay. Now, it says a radius is not a chord because it does not have both of its endpoints on a circle. So all it's saying there is, when we're talking about the radius only goes from the center out to the edge of the circle. The radius is not a chord, okay? Because in order for it to be a chord, it would have to have its endpoint on the edge, on both edges of the circle here, okay? So on both endpoints are on the circle. So a radius does not count, our radius does not count as one of our chords here, okay? In the circle to the left, A, B, C, D, E, F, and are chords, which we talked about that a second ago, and the diameter was EF, okay? Some other things that we'll run into are a tangent line and a secant line, okay? So a tangent line in a plane is a line that intersects the circle exactly at one point. And that point of intersection is called the point of tangency, okay? So for instance, if we look over to the figure on the right, the tangent line would be this guy, okay? It only intersects at one point, so it only touches the circle at one point on the edge here, okay? And that point, point D, that would be the point of tangency. So where we intersect at, that's considered the point of tangency. A secant line is a line that contains a chord of a circle, and an external secant is the part of the secant line that lies outside the circle, okay? So if we notice AB here, just this segment AB, that's a secant, or excuse me, that's our chord based on what we talked about before with a chord, a segment whose endpoints are on the circle. So AB is a chord. A secant line is a line that contains that chord as it goes through it, okay? So it says it's a line that contains a chord of the circle. So this guy right here would be a secant, okay? So secant contains a chord. Tangent, we're only hitting the circle at one point, and that point is the point of tangency, okay? So just kind of pointing some things out there. They talked about the secant AB, chord AB, our tangent CE, and the point of tangency, okay? And we'll talk about how to write the differences here, which this is also based on what we looked at in Unit 1 as well. Okay, so the next thing that we want to look at, which is going to build into what we're going to spend more time on the mathematical side tomorrow, is arc and semicircle, and then we'll look at arc measures and things like that. But for right now, we're mostly just going to focus on the vocabulary, and then we'll build off of that. So an arc is a set of points along a circle defined by a central angle. So if you don't recall a central angle, which we're going to define it later, but a central angle meets at the center here with our two radii, and this would be our central angle. The arc would be the arc that forms between the central angle. For instance, this would be arc DE, okay? But this is actually going to play off of what they're going to talk about in here, which is the difference between a major and a minor arc. DE would be a minor arc, this small arc here, and then if we look at the outside, DFE, this guy would be the major arc, okay? The large arc, okay? So arcs are classified into two types, major and minor arcs. Major arcs have a value greater than 180 degrees, okay? And minor arcs have a value less than 180 degrees. These arcs also have naming conventions. Minor arcs are named using two endpoints such as DE or FD. Okay, now I also put these little arc symbols above. I believe they're actually supposed to have those, so you can add that to it. And I'm talking about like this guy right here, so there's arc symbols. But for instance, this arc that we were talking about here, this would be a minor arc. Okay, and we could call this arc DE. Okay, so for a minor arc, you only need 2 points, and then we can put that little arc sign above it to know that we're talking about an arc. Okay. While major arcs, going back here, major arcs include a third point and 2 endpoints to help distinguish the direction and size of the arc. So if we're talking about a major arc, we're going to have 3 points, two of them being endpoints and a point in between. So for instance, looking at this guy here, in the red, we could call that guy our major arc. Okay, and we could call this arc DFE. Okay, DFE. So it kind of gives you a sense of direction, just like when we talk about an angle. We're going from point D to F to E, so we're talking about that large arc there. Okay. So that's dealing with different types of arcs, so a minor arc and a major arc. Then a semicircle, which we kind of talked about that before, it's an arc whose endpoints lie on the diameter of the circle, okay? So for instance, looking at the figure over here, if we're looking at the arc HMG, that, maybe, HMG here, that would be an arc, but it's also forming our semicircle, and then of course we could go the other direction and say HIG would be another semicircle, but it also represents our arc. Okay, now kind of reading the text here, it says there's no distinction as to whether semicircles should be written as major or minor. Okay, so all that means is we could name, let's look at this arc HMG. Okay, we could name this semicircle as arc HMG. We can name it that way, or we could just name it as HG. Okay, so it doesn't matter if you name it like a major arc or a minor arc. Semicircles are unique in that way. You can use 2 points or you can use 3 points. However, if you're trying to describe a certain side of the semicircle, it would be better to use the 3 points. Okay, that way we know which point the middle point is included to give a sense of direction. Okay, so they give us some examples here. A major arc, ABC. ABC, the major arc, which has a measure of greater than 180 degrees. So if we drew our central angle here, they're talking about this measure right here would obviously be greater than 180 degrees. Okay, then we have minor arc, AC, which, by the way, notice we have 3 points and 2 points for the minor arc, and then we also have our arc symbols. Okay, mark AC, which if we were to draw our central angle here, this would obviously be less than 180 degrees. And then for a semicircle, like I said, you can use 3 points or you can use 2, but we have the semicircle AED, and it's equal to 180 degrees. Okay, so we know that a straight line gives us 180 degrees. Okay. Then it talks about arc addition, which we're actually going to spend some time with this more on the next video. But arc addition just says, because when we're talking about these measures, you're going to find that the central angle and the arc measure happen to be the same. So when they're talking about these arc measures, they say the measure of FG, arc FG, which is 65, plus the measure of GH, which is 95, is equal to the total sum FH, which is 160. Okay, so all it's saying is that we can add up the measures and that gives us the total from F to H there, okay, which we're going to spend some time on that tomorrow. But that's arc addition. I can add up just like we talked about before with segment addition, we can take the 2 small pieces and get the big piece. That's the same thing that's going on here with this arc addition. Okay, now this part actually reviews a lot of what we talked about, so I think I want to do that together with you guys in class, but you can also try and match the figure with what it goes with. Okay, but it just reviews the different vocab that we went over. Okay, I think I'm going to go over 2 and maybe 1 example of 3 here, and then we'll leave everything else for class. And then we'll start from here on the second video. Okay, so looking at this, it says circles A and D have radii of 4 centimeters and 1 centimeter respectively. Use this information to determine the missing values. Okay, so circle A, remember we name a circle based on its center, so circle A, and then we have circle D. Okay, so that's the 2 circles that we're referring to. Circle A has a radius of 4, so we know that the radius goes from the center out to the edge, right? So what we're saying is we have 4 centimeters here and 4 centimeters here. And for circle D, it's 1 and 1. That's our 2 radii. Okay? And we want to use this to determine, it says BF on the first one. Okay, well, BF goes from endpoint to endpoint and through our center, so what is that guy? The diameter, right? So all we need to do is add up our two segments. We know this is 4 and 4, so together BF would be 8. Okay, so the diameter is 8. Whoops. There we go. So our diameter is 8. Then it asks us to determine AD. So AD, okay? Well, that includes 4, but that also includes the radius 1 here from D to F. So together, 4 plus 1 would give us 5, okay? Then on CD, that's kind of forming this side of this triangle here, okay? Now, one thing that's going to kind of help us later on is to recognize that we have another radius here of 1, but we're actually going to come back to that. But let's go back to what we talked about earlier. We said the AD here is 5. Well, if we have this one side of this, notice it's a right triangle, let's see if we can find another side, and then we can use two sides in the Pythagorean theorem to find a third side. Notice that AC here is a radius of circle A. So it has to have the same measure as all the other radii, which is 4. So now, if we break apart our triangle, you can even kind of draw it above here, this triangle that we're looking at. Okay? This guy would be 4, this is 5. What we're trying to find is CD, this guy here. Okay? Well, we can use the Pythagorean theorem to find that guy. Okay? Our a squared plus b squared equals c squared. So we would have 4 squared plus our missing side squared is equal to 5 squared. Well, 4 squared gives us 16. Our missing side squared, 5 squared is 25. Subtract 16 from both sides, and we get our question mark squared is 9. Okay? Then, of course, we square root both sides to get rid of the square. So we get that this guy is 3. So CD here is 3. Okay? And then lastly, it asks us to find CG. So maybe I actually want to move this out of the way for a second because it wants us to find CG here. Okay? Well, if we know the total length of CD is 3, we can use one other thing that I mentioned earlier to help us with this. Notice that DG is a radius of the circle D, which would have to have a measure of 1. And if we know that this total distance is 3, then that means CG would be 3 minus 1, right? If the total distance is 3 and DG is 1, then this must be 2. 2 plus 1 is 3. So CG would be 2, okay? Then lastly, it says find the perimeter of ACD. Well, we found all the sides. We found the sides to be 3, 4, 5. So 3 plus 4 would be 7. 7 plus 5 would be 12, okay? So adding up all the sides of our triangle. All right, one last thing here. I want to look at maybe one example. Well, yeah, let's look at one example. Maybe we can look at B, and then we could try A and C together tomorrow in class, okay? It says on B, draw a secant line. Remember, secant contains a chord, so you're going to have 2 endpoints on the circle. A secant line MN that intersects tangent line TM on circle R, okay? Well, let's just start with this. We know that the circle is R, and we name a circle by its center point. Which point do the secant line and the tangent line both share? M, right? So that tells us that we're going to intersect at M. If they both share M, that must mean they intersect at M. So let's start by maybe drawing our secant line, which is MN, okay? So maybe we have this secant line here, which is N to M. I'm actually going to put M over here. So we have M and N, okay? And that guy would be our secant line, okay, which contains a chord. Then TM is a tangent line. A tangent line only hits it once, but it's going to hit once where we're intersecting here. That could have been a little bit better. Let's try that again. Intersecting once just at that one point of the circle, at point M here, okay? So TM is our tangent line, which at the point of tangency happens to be M, and then MM is our secant line, which contains the chord MN. Okay, so this would be an example of our secant line MM intersecting the tangent line M on circle R. Okay, so the last thing we're going to do in the next videos, we'll talk about the arc length, we'll talk about arc measure, and all of this in the next video. Okay?